Jain friends, myself Sachin Jain, Assistant Professor, Department of Computer Science and Engineering, Ajay Engineering College. In a series of lecture of compiler design, today is the fifth lecture and we will discuss the topic code optimization and its techniques. So, what is the outline? This is the outline of today's lecture. We will discuss code optimization, various types of code optimization, that is machine dependent optimization, independent and machine dependent optimization. And in machine independent optimization, we will discuss machine independent optimization, we will discuss the loop optimization and various types of techniques of loop optimization. And machine dependent optimization, we will discuss people optimization and various techniques of people optimization. So what is optimization? Optimization is a program transformation technique which tries to improve the code by making it consume less resources, that means less CPU, less memory, and deliver the high speed. So these are the objective of optimization. In optimization, high-level general programming constructs are replaced by very efficient and low-level programming codes. So in optimization, we will just convert or we will just replace high-level programming construct to low-level programming code. In code optimization process, we should follow three rules. What are the three rules? First is the output code must not in any way change the meaning of the program. So it means meaning of program should not change when we are performing the optimization, and optimization should increase the speed. So second objective is that increase should be speed of the program should be increased, and if possible the program should demand less number of resources. So we will keep in mind this thing also, and optimization should try itself be fast and should not delay overall compiling process. So process of optimization should also be fast, speed should be increased, and it require less number of resources. These are the objectives of code optimization, or you can say these are the three fundamental rules when we are performing the code optimization. So now, type of code optimization. Basically, there are two types of code optimization: machine independent optimization and machine dependent optimization. So as its name says that machine independent. So in this optimization, compiler takes the intermediate code and transform a part of code that doesn't involve any CPU register or any absolute memory location. So when we doesn't require CPU register and absolute memory location, that type of optimization is called as a machine independent optimization. So let's end with example. So there is a code do item equals to 10, value equals to value plus item, and this is the while condition. So in this optimization, this value that is written inside do construct, I just replace this value outside this do state because the value is fixed. The value is fixed and it consuming the memory unnecessary, because every time we are running this code while loop, this value again and again coming inside this loop. So I just place this item equals to 10 outside this loop and rest of the code is same. So this process should not only the save CPU cycle but also used any but can be used on any processor as well. So this is the example of machine independent optimization. Now machine independent optimization, and next is machine independent type of optimization is loop optimization. So loop optimization is machine independent optimization technique that aims to increase a program's execution speed by decreasing the overhead of the loops. So when we are trying to optimize our looping construct in a program, just to increase the execution speed or decreasing the overhead of the loop, then that type of optimization technique is called as a loop optimization. Since most of the times compiler is spent execution time on loops, so reducing the number of instructions inside the loop will improve the program running time as well, and it will help to execute the code faster. So the objective is to decrease the overhead of loop, and the objective is to increase the speed of the compilation process by just reducing the overhead of loop. So what are the techniques of loop optimization? So first technique of loop optimization is code motion. And code motion is also known as a frequency reduction or loop invariant. So these are the three names of this technique. So code motion is also called as a frequency reduction or loop invariant. So in this technique, we just reduce the number of lines of code in a loop. So in this technique, we will try to reduce the number of lines inside the loop by moving some statement outside the loop. So only those statement or expression that doesn't affect the programming semantics and give same result even after doesn't shifting it outside the loop. So we can do that things just to improve the code. So let's understand this code motion technique with some example. Now consider this piece of code. Here integer a equals to 50, integer x comma y equals to 10, and z value is equals to 10, and there is a loop, while loop. If a greater than 0, then value of x will be y plus z, and if a modulus x equals to 0, then value a will be printed. Now how we will improve this code? So I just write this value same as it is here, and this value x equals to y plus z, that is written where? Inside this while loop. I just write this value outside this loop, because the value of x and y is fixed, and because this value is fixed, and this is just computing, this statement just increasing the computing cost. So I just place this value outside the loop. Now rest of the code is same. So these are the three lines that are same. I just write this value just outside the loop. So in this way, this will not affect the output of the programming. This will not change the functionality of the code, and it will increase the speed of the computation. So in this way, this technique is called as a code motion, or you can say frequency reduction, or you can say loop invariant. Now understand another technique that's called loop fusion. So loop fusion is also the technique of code optimization, and loop fusion is also called as a loop jamming. Sometimes loop fusion asks with the name loop jamming. What is loop jamming? So loop jamming is very similar or a same technique of loop loop fusion. And is this technique we just combine two or more loop which have the same index variable and number of iteration. So when we have two loops or two or more loops where index variable is same and number of iteration are same, so we will just combine those loops, and that's called loop fusion or loop jamming. So in this technique just reduce the time taken by the compiling of all the loops. And let's understand with some example. For example, there is an array A, an array B, and index value I. There is a loop called for loop with iteration 10. There is another for loop with iteration 10 and same index value. Here is I, here is I. So what I will do, I will just combine these two loops and my optimized code will be like this. So basically what's going on, these two loops are just consuming the memory and it just consuming the CPU unnecessary. It will not change the functionality of the program, or it will not change the output of the program. So just combine these two loops and write the statement like this. So this is called loop fusion. Now another technique is called loop unrolling. Loop unrolling is a technique that transforms the loops, and in this technique the number of jumps and tests can be optimized while writing the code two times without changing the meaning of the code. It reduces the number of iteration and it increases the program speed by eliminating the loop control instruction. So here we will eliminate some loop control instruction without changing the meaning of the code. Meaning of the code should not be changed. This is the primary objective of any optimization technique. So let's understand with this with some example. For example, I'm writing integer I equals to 1 and there is two array A equals A index 100, B index 100, and this is the while loop. Now I'm just trying to optimize by this technique called loop unrolling. So what I will do, I will write these two statements same. So whatever change I will do the change inside this loop. So while statement is same, this statement is same, this statement is same. Now these are the two statements that is not written here. So what I did, I just write these statements two times just to reduce the overhead of the loop, and in this way the number of while loop will be 50% less. Right? So this is another technique called loop unrolling. We are just unrolling the loops. We are just reducing the number of iteration in the loop by just writing the line of code two times. Now, another technique of code optimization is called as a machine dependent optimization. Machine dependent optimization is done after the target code has been generated, and when the code is transformed according to the target machine architecture, then that type of optimization is called as a machine dependent optimization, because it depends on the machine architecture. That's why its name is machine dependent optimization. It involves CPU registers and may have absolute memory location that is not possible with machine independent optimization. So in machine dependent optimization, the CPU cycle will be considered, CPU register will be considered, and absolute memory references will be considered when we are performing the code machine dependent optimization. So machine dependent optimizer put effort to take maximum advantage of memory hierarchy. So what are the technique? So peephole optimization is a one technique that come in category of machine dependent optimization, and it is a type of optimization that they perform on a small part of the code, and it is performed on very small set of instruction and a segment of code. So when we are performing an optimization with some small piece of code or with some small set of instruction, and that depends on the machine, then that type of optimization is called as a peephole optimization. So as I told you, that a small set of instruction or a small part of code on which peephole optimization is performed is called peephole or a window. So where we will perform optimization, that piece of code, or you can say that window will be called as a peephole, and that's why its name is peephole optimization, because we are performing the optimization on a very small set of code, or you can say on a very small set of instruction. That's why its name is peephole or a window optimization. It basically works on the theory of replacement, in which a part of code is replaced with shorter and faster code without change the meaning of the program or without change the output of the program. And as I told you, that peephole optimization come in category of machine dependent optimization. So this is the difference between machine independent and machine dependent. Where machine will not be considered when we are performing the optimization, and here machine instruction will be considered when we are performing the optimization. So let's understand what are the different techniques of peephole optimization. So first technique of peephole optimization is redundant load and store elimination. So let's understand with this example. Initially we have a code like y equals to x plus y, I equals to y, z equals to I, and w equals to z into 3. So what I did, I write this statement very similar to like this. This statement very similar to like this. Now what I did, w equals to y into 3 here. Here y, it was z into 3. So when we have z equals to I and I value is equals to y, then why we can't write like this? It just unnecessary consuming the memory. So I just remove this code and I will optimize, my optimized code will be like this. So this type of optimization is called as a redundant load and store elimination. I just reduce the storing element. I just cut out the storing element in this program and just rewrite the code like this. This technique is redundant load and store elimination. Now next technique of machine dependent optimization is code reduction, strength reduction. So let's understand, if we have a code y equals to x into 2, so can I write like this piece of code like this? X plus y will be very similar to x into 2. Or can I write like this? Y equals to x less than x, left shift 1. Yes, we can. So what it will affect, how it will affect, because as I know that star will take more memory, or multiplication takes more memory. So I just replace this star with plus operator, or you can say left shift operator. Similarly, I will replace divide operator with minus or this shift operator. So in this technique is called as a strength reduction. Now next technique is simply algebraic expression. So here the same thing. Here a equals to a plus 0. Here a equals to a into 1. Here a equals to a divided by 1. A equals to a minus 0. So adding the 0, multiply with 1, divide by 1, minus 0 will not affect the value of this a. So I will not write these statements in my program. These are just unnecessary, consuming the memory and as well CPU cycle. So these type of statement we will not use in the program. We will just remove or eliminate from the program. Now replacing slower instruction with faster instruction. Here the slower instruction will be replaced with the faster one, and CPU register plays an important role for doing this one. And for example, a register support unit increment operation will be performed better than adding one to the register. So for example, if I'm adding 1 in some value, and or we can say subtracting one value from an instruction, from a memory, so I can replace this code, add +1 or subtract -1 with increment the register value or decrement the register value. So this will be the faster code rather than this one. Now another technique of machine dependent optimization is dead code elimination. So the piece of code that is not in use will be removed from the program. Understand this one. For example, I'm having a function dead. Here I'm writing a equals to 1, b equals to 5, c equals to a plus b, and I'm just returning this return c. And the rest of the piece of code is integer k equals to 1, k into 2, k equals to k plus b, return k. Now, when I will write a return statement inside a program anywhere, the piece of code will be written here. After the code that is written out after the return statement will not execute anywhere. So this whole piece of code is called as a dead code. So this code we will remove, and this technique will be called as a dead code elimination. So these all about the machine dependent and machine independent optimization. Thank you.